Hello and welcome to this release notes video about ABMT 17. ABMT 17 has a lot of new features and we go through this list here and I show you what's new. The biggest feature are state machines. I prepared a small demo for that. I make a separate video about this, but yeah, display applications are very useful. Every screen could present a state, so here's a small demo with some stuff that you can do with state machines. As I've told you, I make a separate video about that. Here's the demo. You can also download it on GitHub. And here's the state machine. Here are the different screens. Here's the menu screen. So this is what you can do with state machines. And we make a smaller state machine here in this demo. So here we are running the non-mbed version. So here this runs on mbed with a blupill, and this is the demo that runs on your computer. Here you see the same behavior. So in this demo we extend this demo with a small state machine. So we have now a new node here, a system node that's called state machine, and we make a small one here to show you what we've got. So here you can add state variables. We add another output, for example, out. It's like the nodes you already know. Out test, for example, and now we have a test output here. And what we do now, we make a small state machine that counts up and down. So a bit like a counter. So we have our init node. We always need this init node. We can add other nodes here. We call this one countdown. And at the init, we set our output to 0. It's already 0, but we do it here, out 0. And we change immediately to our countdown state, and here in this countdown state we add something to our output, 0.1 for example, and we make another one, rotate this. This is count up. We call this one up because we add up, and when we reach 1, we start counting down. And here in the tick function we set our output. We remove something from our output. Okay, and when we reach 0, we count up again. Out smaller than 0. Okay, let's try this. How is it called? It's called state machine. So here's state machine out. Change this one. So here we see counting up and down. I should have used another scope. Okay, and we can also use a time duration, so we could wait, for example. So let's add a wait state here. Remove my mice. So wait. And we say, okay, we wait 1 second. So here in this condition, in this condition, this was out bigger than 1. And here we say we want to count down after 1 second. So after 1 second, Let's try this one. Yeah, I use another scope here. It's not nice. It's misconfigured. So yeah. So it holds the value 1 second. So this is how to use state machines. Basically, state variables, namespaces includes, and here you have the states with an init function, a final function, and a tick function. And here you can rotate them. Okay, so that's a small introduction to state machines, and I make another video about the state machine here and the display stuff. So let's go back here, see what we have next. Yeah, we have the raster transitions. The raster transitions in pre-ABMT 17 just hold the last value, and now we have other options. Let me show this to you here. Yeah, we stop here at array transition, and now we have a drop down here. We can have the old behavior, or we can have a FIFO and an add or stat value stuff. So let me show this to you, what we have here or how to use it. We use an expression and enter 1. Do this in the 10 millisecond raster, and then we use this output CR type. Yeah, so expression and because we can't see the rate output, we do it like this. And this one is in the 1 second raster. So when we keep the last value, so now let's have this expression out here. This is always 1. So now let's change this behavior. We have a double here, so let's use this add function, and it should be around 10. Ah, yes, around 100. Yeah. So this is now 100, and we can also make this a vector. std vector double, for example, and we vector. So now this wouldn't work, but this would work. So now let's look how many items there are in our vector. Change this here to 200 milliseconds. So now it should be 20. Let's see if that works. No. Ah, yeah. The initialization value. When you use strings, remove the 0. This took me very long to find it. So now data expression out. Ah, yeah. The vector has no add option. Here we go. This works. Yeah, now we have 20 elements in our vector. And we could access the first element, for example. This could break your code. So, because there could be the situation where there's nothing in it. Let's see. Yeah, this is a bad idea. Just don't do it. Yeah. Okay, so that's basically the new rate transition functionality. Yeah, you shouldn't access an element in the expression of yeah, because it could be empty. Yeah. Okay, the next topic, separate header files and source files for each raster. That's something new. Also, state machines are in separate header file and raster file. This saves some compile time and some memory on your system for large systems. Okay, default includes std int, cmath, and string for expressions. Increase connection timeout for slower devices, like this one here. Yeah. And view image scale to image size is a parameter. We have this here. So now you can scale. Yeah. There was a small mistake in the counter node that should now be fixed when you had some accuracy problems. That should be fixed now. So yeah, this one. So copy it in your workspace when you need the update. Okay, expressions now handle true as false as a boolean and not as an input, and the operator, the arrow operator, is supported. So yeah. A dot arrow function true is now possible. Okay, JSON, there's some changes here. The dump function changed. Now it takes the intent as a parameter, and when it's empty, it's a single line output. There's also speed improvements and smaller stuff. Now there's a null type. Yeah. Okay. ABMT now accepts chronoliterals. That's something we had in our state machine. Just see if we find it back. No. Is it still there? Where is it? I deleted it too early. No. It's away. Okay. So yeah, you can say here this after 1 second. This is a chronoliteral, and that's why this namespace is here. Yeah, okay. So the black and white image is new. That's also something you have seen here. And there's special variables. This is also very nice. You can access your node name and the interval you're running in. And when you access the interval, you force the node to be an synchronous raster. I changed this. So yeah, into a synchronous raster. Sure. So let me show this to you. We make a new node here. Test and so I'm lazy. Copy and paste as your friend. So we can access the name and we can access the interval. Let's output this. So here we go. And We take this and let's output the milliseconds. Okay, we need some headers also. And time. So now let's put this node into here and call this in 1 second raster. So let's see. Yeah. Name test. 1000 milliseconds. Let's make this 12 milliseconds. No, that's too fast. 222 and test name. Yeah, so that's how these special variables work. Yeah. The next topic is SPI. Yeah, you can have an SPI interface like the I2C interface. It's all documented in the IO section here. So you can derive from this interface and override this function. This is the only one that you need to make this class work. The other ones you can override to save you some performance. It's basically like the I2C node. Yeah, here you need this function to make it work. Now, there's also a pin interface. This pin interface gives you the possibility to provide a pin to a node without knowing which pin it is, and you can access this pin then as an input. So let me show this here. We have in our display demo in the mbed version, we have here the SPI bus, and here we have O pins and I pins. And yeah, basically, for example, for the buzzy pin, there's a loop that waits until the display is ready, and then you have to pull this pin. This wouldn't be possible with an GPIO input. Well, or it would be also possible, but then you have to have a state machine in. Yeah. So this is just another way to access GPIOs. Now we have two ways here. Okay, so what's next? We were here. Oh, yeah. There's a new asynchronous raster interface. Before ABMT 17, the poll function of a raster returned true or false. True when the raster needs to be executed, and false when it's not needed to be executed. And this interface now changed. And now the poll function returns a time to sleep, and when you want to execute the raster, you return 0. So yeah, this is done to make single thread rasters possible, and to give reduce power reduce power consumption, and to move the sleep functionality to the runtime. Yeah. So yeah, you can look into the interrupt pin node. Interrupt pin node here. It's changed. Here's a sample implementation. You can set a wait time. You can set a sleep time, and then you can decide if you want to have this very fast, or you want to have this very low power, for example, or single threaded enable. So when you want to make it single threaded, you would sleep here for 10 milliseconds or 100 milliseconds and have a wait time for 0. So this is the low power functionality, and this is the high speed functionality. Okay, But maybe I make another video about asynchronous rasters. Let's see. Okay. Yeah, the last thing, very simple, the OS namespace moved to ABMT. We've already seen that here in our test node. Now it's ABMT log and that's not OS log. Yeah? It saves you some space here and some writing time. I think that's it for ABMT 17. Thank you for watching and see you next time. Bye bye.